Hello everyone. In every high school classes, always teachers show us and talk us about the atoms, but they never show us the real picture of the atoms. Today I want to show you the real picture of the atoms of material that all of you have it now in your packet, the smartphone. So let's today open the smartphone and look at the inside the electronic and magnetic materials that are inside the smartphone. So my colleagues in other universities are making a magnetic and electronic material that made of the titanium oxide as a substrate and very thin layer of the ruthenium oxide, 11 nanometer at height. So in the electronic material, the direction of this material is very important. For example, here, the up direction, we call it 110. This direction, we call it 001. And this direction, we call it 1110. For making our life easier today, I call this direction A and this direction B. So what is the problem here? What is the solution? The researcher found that these two directions, we have two different properties. For example, in direction A, I have another electronic or magnetic properties when I move to the direction B. So for example, in direction A, I have a compressed strain, but in direction A, I have a tensile strain. So the question here is why? They come to our group and ask us to look at the interface of these two layers and how is the atomic position of this material. So actually, I am not an engineer. I am a photographer, but my model not people. My model are atoms. And my camera is transmission electron microscope, and you can see that it is 2 times higher than my height. So I put the sample inside the microscope and take the picture. The first picture that I took is from A direction. So this is the sample. This is the A direction, and I took the picture from this direction. So let's see, what does the atom look like? There are layers of atoms. The first layer, that is the white, are ruthenium oxide atoms, and the black layer are titanium oxide atoms. So let's see. In the materials science, when we have something like that, we have a perfect position of the atom in one line, something you can see here. We call it perfect crystal structure. For making my life easier, I changed the mode of this picture to the FFT mode, like changing the TIFF mode to the JPEG in your phone. I have this picture. So each line is the position of the atoms. So if we focus on the interface, we can see that we have a straight line of the atoms. So I understand that when I am looking at A direction, I have a straight line of the atoms. Now I change the direction and take a picture of the B direction. How does it look like? It kind of seems similar to each other, but when I move it to the FFT mode, something wavy shape is happening there. Let's focus that. This stuff. So I have a kind of a straight line here, but these one are not a straight, they are wavy shape. And some part I have a half plane of atoms. What's happening here? So in material science, when your crystal structure is something like that, it's a wavy shape, not a straight line of the atoms, and an extra plate of the atoms, something like here, we call it defects. These type of the defects, we call it dislocation. So what that means? It means that when I am in this direction, I have a full of the dislocation or defects in my materials. So that was the answer for their question. I have electronic materials, and in the A direction, I have a straight line of the atoms, perfect position of the atoms. When I change my direction to the B direction, I have many defects, dislocation. For this reason, in the A direction, my electronic and magnetic properties are completely different with the B direction. So if you want to talk about atoms more, better call us. Thank you.